All right, now let's go into 6.5. So we're in section 6.5. We're supposed to cover 6.5 and 6.6 in the next half an hour. We'll see what we can do. X squared plus 2x plus 1. All right, number 1. This is 6.5 is an easier, well, the beginning of it anyway is easier. So x squared plus 2x plus 1. What they want me to do is they want me to factor that. So actually, you guys know how to factor that already. First step is what's in common to all the terms? Nothing. It's good we looked for it, though. There's nothing in common. So I'm looking for two numbers that multiply to be 1 and add to be 2. Multiply to be 1, add to be 2. So what two numbers multiply to be 1? 1 and 1, huh? 1 and 1. So this one is simply x is in the front, plus 1, plus 1. It's really not anything new, huh? Now we think, well, why are they giving me the same thing again? You know what it is? It's this. It's a repeater. What do you do when you have the same exact thing twice?
Square it.
You just put a 2 power on it. Yeah. That's it. I mean, that's all that's new. Now, there's other things in this section, but this first one is not really new at all. The only new part's that last step, because you have identical twins, the same thing twice, then it's squared.
Is that what you were going to ask for?
Actually, it's fine either way. The actual test we take in 3 weeks will be multiple choice. So they won't have both answers. They'll either have this or they'll have this. It'll look like this. And you'll just bubble it in. You'll just grab that answer. The quizzes, Math Excel will take it either way. Homework and quiz, Math Excel takes either one. Does that make sense? So there's really almost nothing new to that problem. It's just, same thing twice, that's squared. The rest is stuff we already know how to do. So that's the beginning here, is really the same stuff. Let's look back. So number 2, okay, I'll do it with you. It's going to be the same thing. 25a squared minus 60a. So number 2, 25a squared minus 60a plus 36. Like that. Okay. So let's try that one. Yeah. What's the first step on every factoring problem? GCF, huh? What's in common, if there's anything? Is there some number, you can check in your calculator, is there some number that goes into 25, 60, and 36? Really not. No. So skip that. We're not going to do the one big parenthesis step. Go right on to the 2. So we're moving towards the diamond thing then. So what's our next step? Slide and divide, right? So take this. So really this is the same. Slide it to the back. But let me give you a hint. You're looking for identical twins. This one's going to end up being identical twins also. So just kind of have that in the back of your mind. And how do you know? 25, that's what? 5, 5. 36, that's what? 6, 6. See how they're kind of setting it up to be identical twins? Kind of see it coming? If you could just write down the answer right now without doing the diamond stuff, that's fine. Some of you might be comfortable with that. It saves some work. Totally fine. You know what I mean? If you can just look at it and go, okay, look, I can tell, Mr. Heron, this is one of these same thing twice. Let me just do that with you. Maybe that'd be easier. What times what's going to be 25a squared? Yeah, 5a, huh? Front times front to make front. Now, what times what is 36? 6 and 6 to make 36. With me so far? How can two things multiply to be 36? Remember, they always add to be, they multiply to be the end, they add to be the middle. I'm just skipping the diamond, basically. What times what is, what signs do we mean? I'm sorry, what signs, how do two things multiply to be positive, add to be negative? They're both negative. Two negatives multiply to be positive, don't they? They multiply to be positive, and they add to be negative. Now, did I confuse you by doing that? I skipped the diamond, I skipped the slide and divide, and I just went right to the answer. Now you think, why don't we just always do that? Well, they're not always that easy. They're not twins, usually. That one's only nice, and you can kind of skip the slide and divide and the diamond thing, because the numbers are so nice. If you foiled that out, hey, how would it really make 60? Is that really right? It is right.
It is right. You know how you can check it? You don't have to do this. Just watch me do it. Here's how you would check that it's really true. If you FOILed this out, you see what you would get? 25a squared minus 30. See what I'm doing? I'm multiplying it out, foiling it to see if it would really go back right. The first one goes to both. Remember how to do that? First to both, second to both. And then this one goes to both. Minus 30a plus 30. See how it makes the minus 60 in the middle? It is right. That is the right answer, huh? We just verified it. Now, I skipped the slide and divide, and I skipped the diamond. If you want to do those, let me just get rid of this. You totally can. We would get that answer. Here, let me show you. Let me show you all the steps. It would just be more work. You would just say, okay, slide this to the back. I'm just going to do it longer now in case I'm confusing you. That would be some big number, 900. And then you'd put the 900 up here. What multiplies to be 900 adds to be minus 60. And you would think what? What times what's 900? We're thinking about twins. What two numbers make 60?
30 and 30.
30 and 30, both negative, make minus 60 multiplied to be 900. So you see, we're going to get the same answer this way. And then you get A, get rid of that there. Then you get A minus 30, A minus 30, like that. And then you divide, go back and divide by the 25, right? Slide and divide, and then you reduce that, top and bottom by 5, top and bottom by 5, and you get A minus 6/5, A minus 6/5, and then you slide the 5s back. And just like we knew, 5A minus 6, 5A minus 6, same thing twice. That's 5A minus 6 squared. So either way, either formal slide and divide like usual, or just kind of spot it early on and go, oh, look, 5, 5, 6, 6, it's one of them twins. I can just write down the answer. Either way, whichever's fine with me. Is that okay? So slide and divide will always work for you. You don't have to do anything new. Right? You can just do the old methods, will work fine. Okay, 1 plus 7x squared plus x to the 4th. 1 plus 7x squared plus x to the... Is that number 7? No, it's number 4. Okay. Let's try that one. If you could reorder that, huh? That's out of order. You want to go from highest power to lowest? You could reorder it. So I'm going to go from highest power to lowest like that. Hey, that doesn't factor, does it? Am I missing something? I'm thinking that's not factorable. Am I missing something? Did I copy that down right? Oh, yeah. Yeah. Prime. Prime means not factorable. This one's not factorable. Why not? Well, if you try to do the multiply, add thing, you know, what two numbers multiply to be 1, add to be 7? There's no numbers. So the answer on this one is prime, which is a word for not factorable on that. Thanks. I appreciate you getting that. Prime, not factorable. Why don't we just, why are we saying that all of a sudden and we don't say what we did a minute ago when they wouldn't factor? We just say we're done, this is the answer. That might be in your mind. It would be in my mind if I was you. I'd be thinking, wait a minute, why all of a sudden are we saying prime not factorable? And a minute ago when the diamond didn't work, we just said, that's just the answer. Because we didn't even take a step here. Do you see the difference? I didn't even do it. The horses are loose. How about that? They're not even contained in parentheses. Nothing's contained. We did nothing on this problem. Those other ones, when the diamond didn't work, and I just said, okay, that means we're done here, we'd already done a step. We'd already done the GCF step and taken out the one, what's in common in the one big parenthesis. So all the horses were contained. It was okay to stop. It's not okay to stop here. We haven't done anything. That's why it's prime. Everybody see the difference? So when the diamond doesn't work and you haven't even done a step and the horses are loose, that's not factorable. That's called prime on that one. So this one is 5 times 5, and this one is 4x, isn't it? You guys tracking with me? That's 4x, 4x. That one's 5, 5. They're both something twice. They're both twins, aren't they? They're both, I call them a double-double because I like In-N-Out Burger. It's a double-double. It's that nobody calls it that but me. It's a difference of squares. But I like double-doubles help. It's something twice, right? That's what they are. It's a 5, 5, 4x, 4x. When you see that, this is going to be your favorite kind of factoring. It's super easy. You don't need to make the diamond. You don't need to mess around with anything. Just do 2 parentheses. The 5s that were on the left, they go in the left of each parenthesis. The 4x that was on the right goes in the right of each parenthesis. And now I need the signs. What signs might it be? How are they going to multiply to be negative 16x squared? How can a 4x and a 4x multiply to be negative? One positive, one negative. Either order doesn't matter as long as one of them is positive, one of them is negative. Doesn't matter which one's where. Either way on that. Is that making sense? And we're done. Nothing more to do. The horses are contained. We're done. Just like that. Good on that? Questions on that one? Can I help you, sir?
I just wondered, I know.
It's very. I've taught 25 years. I don't remember such an interesting night. All right, there we go. It's normally just business, math. All right. So does that make it? This will be the easiest kind of factoring. Double, double, difference of squares. You just go 5, 5, 4x, 4x. The 5's go on the left, the 4x is on the right. 1 plus 1 minus, because that makes negative 16x squared. Okay, let's try number 7, x cubed y. X cubed y minus 256xy cubed. Okay, this is number 7, right? Yeah. Number 7. Okay. So try that one. So what's the first step on every factoring problem? No matter what new fancy techniques we're learning, what's always the first step? GCF, right? So take out what's in common. That's always first. Don't ever stop doing that. They have some letters in common, right? So what goes into both of those? What do they both have? You got to get all their commonness out. What if I just took the x? Let me that's wrong. Let's see how you would know that's wrong. If I just took out x, I would have that. How would I know I had not gotten all of the commonness out? How would you know? What's telling you, hey, there's more. So yeah, they both have y still, huh? So there's also y in common, so you have to also do that. So x and y come out, get rid of that, and this goes to 2. Better? Good so far? So that's always, notice how that's just always our first step. If there's something in common, got to do that before you do any other, whatever, diamond, difference of squares, whatever. Now, can we do more? Well, the horse is contained. Maybe we can stop, but maybe that can go further. Can this part go further? Yeah, because it's a double-double, isn't it? It's a difference of squares. So go ahead and go further with the difference of squares there. It's a double-double thing. So in other words, this is x times x. Now 256. Do you have your calculator? Hit the square root button. That's what square root does. It says what times itself is this thing. That's what we need to know. 16, right? You get 16. 256, hit the root, and it'll tell you 16. And so then you go, oh, this is 16y times 16y. It's a double-double, isn't it? XX, 16y, 16y. With a minus. By the way, they're going to try to fool you. They're going to throw a curveball at you in a minute. Let me just give you a heads up now. You've got to have minus in the middle when you do this double-double thing. If they put plus in the middle, it seems like it should just be the same. It actually doesn't work at all. I'm going to write all this out in a minute. But just heads up, it's got to have minus in the middle. If it had plus in the middle, we would stop right here and be done. We'd be done because the horses are contained. We're done. You can't go further if it has plus. But if it has minus, double-double, take another step. So it's double-double. So the xy that's in the front just stays there. And then I do my 2 parentheses. And remember how double-double works? The stuff that was in the left goes left, left. The stuff in the right, 16y, 16y, goes right side, right side. And how do they make negative?
Positive, negative.
One positive, one negative, either order, doesn't matter, done. That's the answer. Double-double is the quickest factoring. Does everybody see it? Don't need to make diamonds or anything. Questions on that? All right. Okay, so try number 8 there. So if you're looking at that right now, and you're saying, oh, what am I going to do? It's not 20, that's not really, is it 10 tan? No, that would be right, we're not adding, it's not 10 times 10, is it? So that's not working. 125, that's not a double, what's going on here? I don't know if anybody's doing that, but that happens sometimes. And so if you're doing that, the thought that you want to think instead is, what's the first step on every factoring problem? GCF. Do that first, and then things will make sense. So do the GCF first. Take out what's in common first. They have, 5? Yeah, the second week. So, okay, maintenance firm?
Yeah.
Fill this out, turn that.
Yeah, no, you can figure out tomorrow, I already have to do that.
Gotcha. Yeah. Okay, they open at night. I'm only at night.
No, they ain't gonna be open tonight.
Like, I'm just gonna, like, I'm choosing that.
Okay, what time?
7 o'clock.
Yeah, somebody.
Okay.
Yeah,
Okay.
yeah.
Thank you, sir.
Yeah.
So take out the 5 first, right? Take out the 5. And then you'll see a double-double, right? And so take out the 5. That'll be 4r squared minus 25. Is that good? Like that. And then that's a double-double. Do y'all see that? 2r, 2r. 2r times 2r is 4r squared. 5 times 5. 2r, 2r, 5, 5. Double, double, right? So that means we leave the 5, and that's our favorite kind of factoring. 2 parentheses. The 2r's go in the left, because 2r times 2r will go back to 4r squared. The 5's go in the right, because 5 times 5 is 25. But how do you get negative 25? One positive, one negative, either order, doesn't matter, one of each. Done. That's good? So always do that GCF first, or nothing will make sense. It'll look totally weird. I always have students, every exam, I'll have a couple people go, Mr. Tarrant, I totally stuck on this one, and they're good factors. And I'll say GCF. And then they're like, oh, I forgot. So to remember that GCF. Nothing, you get messed up, you don't remember that little GCF. Always the first step. Take out what's in common, if there is something there. About half the time there is. So 10 will be x plus 3y squared minus 64. Okay. Do you see that one is just a big fancy double-double? They're just making it bigger. This is what math is about. This is the heartbeat of math, the patterns. Do you see the pattern? Let me write out the pattern. I hope you don't feel like I'm treating you like a kindergartner or something. I don't think of you that way at all. So I'm going to draw figures, but I'm just trying to make it as simple for myself and for everybody. Let me show you the simple pattern. What we've seen in the double-double pattern is if you have something twice, right? This means triangle, triangle, doesn't it? This means O, or circle, circle, whatever, right? When you have something twice, double-double with a minus in the middle, what's the pattern? You put 2 parentheses, you put 1 triangle on the left of each side, 1 circle on the right, 1 plus 1 minus. That's the pattern. You always follow that double-double pattern when it fits, no matter how big or small they make it. Well, they're just trying to trick you by making this bigger and putting a parenthesis in whatever. Who cares? It's the same thing, right? What is this? This is, let me write it up here like I usually do. This is x plus 3y, x plus 3y. And this is 8 times 8. It's a big double-double. It doesn't matter that this one's big and has its own parentheses. Whatever. That's what math is all about. Once you see the pattern, you just follow the yellow brick road. Just follow that pattern. It'll work. It'll work. And they try to trick you by making it big or making it look different. But your job is to really be honed in on that pattern, bless you, and just follow that pattern. So what's the pattern again? What's the pattern over here? When you see something twice, you put 2 parentheses, left, right, 1 plus, 1 minus, huh? Let's do that. 2 I have room here, bring it down a little bit. So 2 parentheses, left, one of these, x plus 3y, x plus 3y, left and left. What's on the right? 8 and 8. And what goes between them? 1 plus, 1 minus. Done. Do y'all see how that's just that's the same thing, just bigger? Same exact pattern, just larger. Good? It's all math is. Math is just patterns. It really is. Questions on that one? Got a couple minutes. They're important. But there's one other major concept in this section. In our last couple minutes together, I want to show it to you. So number 13, r cubed minus 125. This is going to be a triple. You shouldn't eat those in In-N-Out Burger. Triple. So that's r. That's right, something 3 times. So that's r times r, as you know. And what about 125? You have a calculator? Maybe you just know. What times what times what 3 times, multiplied by itself 3 times, is 125. If you're not sure, just take 7. Oh, that's too big.
5.
It's 5 times 5 times 5. Yeah, just guess on your calculator. You'll find it in a matter of seconds. This is 5 times 5 times 5. So it's a triple. So everybody see that? That's not what it's called officially. That's just my little name thing. They call it this one would be a difference of cubes. It's third power. Whatever you want to call it. It's a triple, so it's different than the double. This is the other major formula I want to show you in this section, right? We've got just a couple minutes. Hone in with me on this. I'm going to give you the pattern. It's a little complex. It's not quite as simple. You get a 3x5 card on the exam in 3 weeks to write anything you want, front and back on a 3x5 card. This would be a good thing to write on that card. Yes, sir? I gotta get you through this triple thing. Okay, it's a little different the way it works. Triple. So let me give you the pattern. It's all about patterns. Here's the deal. You're going to do, see how there's 3 R's and 3 5's? You're going to basically, it's probably not what you would think. There's not 3 parentheses. There's 1 little parenthesis and 1 big parenthesis. 1 little, 1 big. The little one has 2 things. The big one has 3 things. Probably not what you would guess. Okay, let me show you the pattern. Here's how it goes. See how we have these 3 R's that are on the left? You put one of the left items left, one of the right items right, and then the other 2 left items in the left of the big parenthesis, the other 2 right items, 5 times 5, 25 in the right. Let me slow down for a minute there. I'll write all this out as a pattern in a second. Also, in fact, let me just do that right now. Let me just go L cubed minus R left minus right cubed. What's the pattern? Little parenthesis and a big. 1 left, 1 right, 2 left, 2 right. Everybody seeing that? Because this is 3 L's, isn't it? And this is 3 R's. So I put 1 on the left, 1 on the right, 2 on the left, 2 on the right, and 1 of each in the middle. Even though you might go, well, there's no more left. Whatever. It's just a pattern. You put 1 of each in the middle. So 1 left, 1 right, 2 left, 2 right, 1 of each in the middle. No signs yet. I'm going to show you a special rule for the pluses and minuses. That's a separate special rule. Everybody good with the placement so far? 1 left, 1 right, 2 left, 2 right, and 1 of each in the middle. And now how do you do the signs? The thing everybody uses is you soap the signs. Soap, same, There's got to be a sign here, there's got to be a sign here, and a sign here, right? Same, opposite, always positive. Soap. Same. Same as what? Same as whatever you started with. So if you start with minus, it's the same. Next, it's opposite, so that'd be plus, huh? Opposite of what you started with. And the last one is always positive, no matter what you started with. Always positive. You soap the signs. Same, opposite, always positive. That's it. That's the pattern for factoring a triple-triple. You can do a triple-triple minus or plus. Remember the double-double was only minus? Let me write that. Double-double only works for minus. But triple-triple works for both. Triple-triple could do plus or minus. So that's good stuff to put on your 3x5 card. All right, let's go back and finish this one up then. So 1 left, 1 right, 2 left, 2 right, 1 of each, 5R, R5, whatever, it doesn't matter. 1 of each in the middle. See how I went? 1 left, 1 right, 2 left, 2 right. 1 of each in the middle comes R, 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 5, 5, 5. So 1 left, 1 right, 2 left, 2 right, 1 of each in the middle. And then we soap the signs. Same, opposite, always positive. Same as what we started with, minus, opposite, always positive, done. That's the pattern for triple-triple. Now, we've only done the simplest one, unfortunately.